Alright, in this problem, in 1624, an explorer convinced a group of indigenous peoples to sell him an island for $26. So if those peoples had put the $26 into a bank account paying 7% instead, how much would the investment be worth in the year 2005 if interest were compounded monthly, and then we'll find what it would be worth if the interest were compounded continuously. So how much would the investment be worth if the interest were compounded monthly? So for that, we're going to use the compound interest formula. A, the amount after t years, equals the initial investment times 1 plus the interest rate over n to the power of nt. Now, n is the number of times that it's compounded per year. So if we are finding what it would be worth if it had been compounded monthly, that tells us that n is 12 times per year. The interest rate is the annual interest rate, which is 7, so 0.07. And let's see, t, the number of years, that we're going to have to compute here. So t, we're going to use 1624 as the initial year, and 2005 is the later year. So how many years elapsed between 2005 and 1624? Okay, so we're going to do 2005 minus 1624 to get 381 years. Okay, plugging all of this into this formula, we want to solve for A. The initial amount was $26. Interest rate is 0.07. T is, I think I wrote that wrong. I should have said 381. Yes, I don't know why I wrote 38T. 381 for T, so times 381. There we go. So this is something that we'll just have to type into the calculator. Obviously, it must be a pretty big number since all of our options are quite huge. So what we're going to do is, first I'm going to do 12 times 381 because just make a note of that. Okay, 12 times 381 is 4572. So we have 26 times 1 plus 0.07 over 12 to the power of 4572. Okay, so we're going to do 1 plus, or no, actually let's do 0.07 divided by 12 to get that. Now we're going to add this 1 right there, so plus 1. We're going to raise that to the power of 4572 and multiply that times the initial amount of 26. Wow, that's a large number. Okay, let's, I'm going to go backwards here. 894. None of them are ending in 894. I have a feeling that this is because, no, 498 I mean, that this is because of the years elapsed is my best guess. Okay, so I've tried it with using 382 years simply because if you started at the beginning of year 1624 and you went to the end of year 2005, that would be a full 2 years elapsed instead of 1 year, but I didn't get any difference. So I think what it is it just comes down to calculator error, to be honest, because there's so many decimals here. So let's type this in one more time. If I do 0.07 over 12 and add 1, and I raise that to the power of 4572 and multiply times 26. Okay, this is actually pretty close to this first answer. What are we? I don't even know. Trillions. 203 billion, 548. We're still the same. Then 458. We're the same to there. It's the last 3 digits that are off by a little bit. But when you raise a decimal to a power, to such a large power, that could be calculator error. So we're going to go with A on this. So let's hit A and okay. So yeah, calculator error there because the numbers are just so big. How much would the investment be worth if money were compounded continuously? Okay, so for this one, if interest is compounded continuously, that means we're using the formula A equals PE to the RT. So what we're trying to find is the amount after T years. The initial principal was 26, the interest rate was 0.07, and the number of years was 381. So this is, again, something that we're just going to enter into the calculator. So we're going to do, I'm going to do 0.07 times 381. Okay, it's 26.67. I'm going to add that to my memory just in case. Then I'm going to hit the E button. I think that does, yeah, that definitely does E to that power. And we'll multiply times 26 to get, let's see, 9, I think we were in trillions, 945 million. Looks like we're on this one. At the end, it looks like this one actually comes out exactly with the calculator, no issues there. So, okay, so part D on this one. And there we have it.